For a century, there have been gumball machines to give us something to chew on. Vending machines that dispense gumballs were introduced in 1907 on a New York City subway platform. Today's gumball machines are more modern versions of the originals. But to young and old, they still represent treat time. The gumball machine is all about instant gratification. Insert a coin, turn a handle, and out comes the merchandise. To make a gumball machine, a designer first sketches out the exact proportions. Then, a worker ladles molten zinc into a holding furnace, where a steel plunger pushes the metal through a die that forms a gumball machine base. A mechanical claw removes the newly shaped base from the die and places it on a conveyor belt to cool. A similar die shapes the coin mechanism handle and drive gears. A worker places a braided hose with a natural gas flame under a mold that will shape the gumball dispensing chute. He pours piping hot liquid aluminum into the mold. The flame below warms the mold enough to prevent condensation, which would ruin the shape. But the mold is still cooler than the aluminum, and that allows it to solidify into a chute shape in seconds. Now, using a punch press, a worker trims the waste away from the lid for the gumball machine. They also trim the front plate of the coin mechanism using a similar press. A computerized cutter mills out a hole in the top of the globe that will hold the gumballs. The globe is made of shatterproof plastic. At another station, they press the base of the gumball machine against a cloth-covered buffing wheel to give it a shine. A worker now assembles the coin mechanism, layering the front plate, the coin carrier, the back plate, and ending with a cam, the part that ensures the coin mechanism moves clockwise. She screws it tightly together, then inserts the handle on the front plate. The handle will turn the coins that pay for the gumballs. She places a little spacer and drive gear on the handle stem that protrudes through the back of the assembly, and then screws the drive gear onto the handle stem. Now it's time to put the money up front. They insert a coin in the slot and turn the handle to make sure the system works. People in many countries like gumballs, so these coin mechanisms can be made to accept currencies from around the world. They can also be used in other types of vending machines. Now they spray powder paint onto the lids, giving them a 3 mm thick coating. They bake the paint onto the lids at 204 degrees Celsius for 25 minutes. Now it's time to pull all the pieces together. They place the dispensing wheels in hoppers, then cover them with a part that stops free gumballs from spilling out. The next part is the adapter ring, and the plastic globes fit on top of them. They place aluminum rings on top of the globes. Then they slide 2 side rods through the top rings, down into the bottom of the globes. They screw them down very tightly, and then set the assembly aside. Now they place plastic bodies on bases, and install the chute doors on the front. They place the chute covers in the plastic body and mount the coin mechanisms just above the chute. Next, they slide the globe assemblies over center rods and onto the plastic foundations. They put a lid on every globe and then lock them on. And now, we're at the vending part of the story. Gumball, anyone? The job it does is exhausting. The exhaust system on your vehicle gets rid of harmful gases that could damage the engine. It also cleans up the gases a bit before venting them into the air. A properly functioning exhaust system does another big job, muffling the airborne noise of the engine, and for that, our ears thank them. It's a system of metal tubes and plates we only seem to notice when it breaks down, and then the muffler's importance is loudly driven home. To make an exhaust system, a mechanical puller draws a stainless steel strip up into a punch press, shuffling it back and forth to allow for a precise cut with little waste. The press brings 60 tons of force to bear as it pushes the steel into a die. It punches out a baffle shape with holes in it, which will form the skeleton for the muffler box. The finished baffles fall onto a conveyor and go into a storage cage. Now, a long steel tube tumbles to automated blades, which score the tube crosswise to prevent denting, and then cut it to produce smaller tubes that go inside a muffler. A circular saw descends on another tube to make a tailpipe. Its length depends on the type of muffler being made. A louver machine spins and punctures one of the inside tubes. The holes will regulate airflow in the muffler. A CNC bending machine grips and bends a pipe in several spots. This is how they make inlet, intermediate, and outlet tubes. These tubes run the length of the exhaust system. Then they place a tube in a circular hydraulic vise, which pinches the end down to a prescribed diameter to allow for further assembly. A worker now places two baffles in a jig. He fits the tubes through the holes in the baffles so that the tubes connect the baffles. 3 mandrels slide into the tubes. The mandrels expand, locking the tubes to the baffles. Then they contract and slide out. Now the baffles and tubes are one piece. Next, a robotic arm picks up metal sheets which will become the outer skin of the muffler box. It pushes them under an oval mold. Another arm with numerous rollers on it moves up and wraps the steel around the oval form. Then a metal block moves over the ends, double folding them. This locks them together, and it completes the assembly of the muffler's outside skin. Magnets pick up the new skin, and, sliding on rails, they relay it to a mechanical claw, which in turn feeds it to a flanger. The flanger bends the edges, creating a lip on either end of the muffler skin. A carousel turns, and a mechanical claw transfers the newly flanged muffler skin to the stuffing position. Hydraulic pushers press the pre-assembled baffles and tubes inside the skin. After the muffler is stuffed, the robotic claw transfers it to a conveyor belt. Next, a worker presses each end of the muffler against a set of steel expansion fingers. The fingers move forward into holes in the muffler. They expand and lock the baffles and tubes inside to form one solid internal unit. Grippers place the muffler on a spinning machine that will fasten the caps on. Rollers press against the flared edges of the revolving muffler, tightly locking the end cap to the rest of the body. Here you see the rolling in slow motion. It takes only a few revolutions to do the job. Then the rollers back away, and a mechanical arm grabs the muffler and transfers it to a conveyor belt. Now these mufflers are ready to help keep the traffic din at a minimum.